So our next presentation is actually from NHK, Juji Nagata, a Japanese broadcast corporation. He's as an engineer working at the NHK, and he's going to share with us content production technology on hybrid log gamma findings. So, Juji, please come up. Here we go.
Thank you for introduction, Mr. Chairman. Good morning, everyone. My name is Yuji Nagata. I'm a broadcast engineer with NHK and in charge of development for 8K content production. Today, I'll talk about content production technology on hybrid log gamma. Thank you. In this talk, I will follow this outline. I will introduce the basic technology for 8K super high vision system, then discuss the development for simultaneous production. I will provide some conversion application examples and discuss the resulting production data. Finally, I will end with some overarching conclusions. First, the basic technology for 8K super high vision system. This 4K, 8K ultra high definition TV is called Super High Vision or SHV, which is brand name in Japan. 8K Super High Vision is a broadcasting medium featuring 16 times the number of pixels as HDTV. And it includes 22.2 multi-channel sound to provide a highly realistic sensation as if you are there. In addition to the incredible resolution, Super High Vision features a dynamic range, color gamut, bit depth, frame rate, and sound. Next, let me show you the basic technologies implemented in SHV test broadcasting. Before REC 2020 wide color gamut and HDR high dynamic range were standardized, we had already developed many types of 8K equipment. We product 8K programs using two types of equipment. One only supports REC 709 SDR, and the other supports both REC 709 SDR and REC 2020 HDR. As you can see, the programs are broadcast from the SHV master control system at NHK headquarters in Shibuya, Tokyo. Currently, the programs are broadcast to NHK headquarters, 53 locations, and a few other locations. In these locations, SHV broadcasting is received on a specialized receiver and displayed on an 8K projector. SHV test broadcasting only supports REC 2020 in the color gamut. When we produce programs using REC 709 equipment, we have to convert them from REC 709 to REC 2020 in addition. We provide a public viewing service. The projector only supports REC 709 SDR. Thus, we have to convert between HDR REC 2020 and SDR REC 709. In 2 years, December 2018, we plan to begin SHV broadcasting. During the tests, we broadcast 8 per day in SHV. for broadcasting, we are going to extend our broadcasting hours, so we will have to produce many additional programs. However, our maintained broadcast service is still HDTV, and we will have to produce HDTV programs as we do now. Therefore, our workflow simultaneously producing 8K, 4K, and HD is necessary. Thus, we developed a converter. Here are the required functions for simultaneous production. Color gamut conversion between Rec 2020 and Rec 709. HDR SDR conversion, which called gamma conversion. Resolution down conversion, 8K, 4K to HD. Real-time processing. We developed two kinds of converters to satisfy these functions. One is a high-performance down converter. The other is an 8K, 4K, HD gamma converter. Next, before I explain the gamma conversion, let me explain the transfer function. These are the transfer functions for HLG based on ITU-R Recommendation 2100, BT.2100. The input is shot with a camera, and the output is shown on the display. In this camera process, scene light intensity is converted to signal using HLG OETF, which is an optoelectrotransfer function. Then, an HLG inverse OETF and HLG OOTF are used in the display process. The graph shows an HLG OETF and EOTF. The HLG OETF consists of two curves, Rec 709 and log curves. This graph on the right side shows a system gamma of 1.2. In this case, the maximum display luminance is assumed to be 1,000 candela per square meters. Next, I'll explain the gamma conversion method. There are two types of conversion methods, scene referred and display referred. For the scene referred method, we convert the signal from A prime to B prime based on the consistency of scene light. These are the equations involved in the conversion. We can also convert the signal from A prime to B prime based on the consistency of the display light. These are the equations involved. In the display referred method, A double prime equals B double prime. These are the gamma conversion method. Now let's look at how to use scene referred and display referred conversion in actual use cases. The schematic shows the process for using the scene referred method in practice. When we produce an HD programs using an 8K camera and HD camera at the same time, we have to convert the output of the 8K camera. In this case, the conversion is based on the scene referred method. The reason is because we can adjust each camera setting individually, which is required. On the other hand, we can use the display referred conversion to convert pre-produced content as shown. In addition, convert the output of the switcher and produce 8K program and HD program at the same time. We use the display referred conversion. Here, I will describe the high performance down converter. This table shows the specification of the converter. This converter supports both 8K and 4K signals as inputs, HD signals as outputs. In this conversion, color gamma, and resolution are processed almost in real time. In the process of gamma conversion, we can adjust these parameters. This is a diagram of the process used in the converter. This case shows the conversion from HLG to SDR. This conversion is based on the display referred method. In this flow, the first conversion is resolution down. The second converter is an 8K, 4K, HD gamma converter. This converter supports 8K, 4K, and HD signals for both input and output. The difference between this converter and the one I explained previously is that this converter supports interactive conversion, but does not support resolution down conversion. In addition, a linear matrix is used in this color gamut conversion because of memory capacity restrictions. This converter supports conversion between PQ and HLG as shown in this flow. This process is also based on the display referred method. In this conversion, we can choose the maximum luminance and system gamma separately in the converter. The current version of this converter does not automatically support PQ metadata. After carriage method of PQ metadata on SDIs will be standardized, we plan to support it. Now, I'd like to provide some example of conversion applications. I'll now show you the most recent applications of the converters: programs, TV drama, documentary location shooting, live sports. After that, I'll show you the parameter to produce HDR content such as video levels of HLG. We are verifying the converter for some operations. This is an example of the conversion application for drama, where verify the simultaneous production. We converted from 4K Rec 2020 HLG to HD Rec 709 SDR. Two video engineers process the color grading on filming site. One engineer processes the HDR content using the color grader and verifies the SDR content, which is automatically converted from HDR using the converter. The other engineer processes the SDR content using the color grader. The SDR content converted using our converter was better than SDR content converted with other systems, especially for dark and brightness areas. In the other system, operators said the gradation was lost in the dark area and banding artifacts were occurred in bright area. We would like to reduce the number of operators for more efficient production. Next, let me explain the workflow for this documentary. In this example, the converter is from 8K content to HD content. After filming and editing roughly, we play the 8K footage in a baseband signal from the 8K recorder. And then, using the converter, we convert all the cuts. Next, we process some of the cuts that need the level adjusted and convert the resolution down from 8K to 2K with the editor. In this workflow, by the process combined of the bulk conversion and accurate adjustment, we reduce the editing time dramatically. Finally, I will describe the system overview for live sports. This is a conversion from 8K HLG Rec 2020 to 8K SDR Rec 709. Basically, we use an OB-band. As you can various equipment such as multiple cameras, subtitle equipment, and others are connected with the switcher. As for non-live program, we can produce both HDR and SDR by adjusting the footage grading during post-production. However, as for live broadcast, we have to process them in real time. So a converter must be used for a bulk conversion. To avoid adjust footage independently for HDR and SDR, we have to set the fixed parameter for live broadcasting. At present, because there is no 8K subtitle equipment right now, we use the up-converted subtitle signal output from HD or 4K to 8K. 8K 4K HD gamma converter is used to convert from 8K SDR Rec 709 to 8K HLG Rec 2020. It's very important to set the appropriate gain value for SDR. If you don't set the appropriate value, the superimposed text will be either extremely bright or extremely dark in comparison to the overall footage. In addition, we choose to use the gamma converter to convert from 8K HLG 2020 to 8K SDR 709. Because after confirming condition on a SDR monitor, we found that the 8K projector used for public viewing was not compatible with HDR Rec 2020. Next, here, I'm showing the considerations that need to be made when converting HDR mastering to SDR. If mastered in HDR and then converted to SDR, two conditions result. One is the high exposure to show the girl. The other is the low exposure to show the background scene mainly. In the conversion, exposure is varied according to your creative intent. SDR is a narrower expression than HDR. We don't want to adjust footage independently for HDR and SDR. Therefore, exposure level must be adjusted with a focus on production in SDR. Production data. When producing content using multiple cameras, the manner in which light is reflected changes when the same subject is shot from multiple camera positions. It is therefore necessary to confirm conditions on a master monitor or a mastering instrument while using camera remote control to calibrate the color and exposure in real time for one or multiple cameras. Adjusting all cameras to provide a consistent tone that considers production intent can result in footage quality that withstands the rigor of broadcasting and that does not suffer from tonal shifts when switching cameras. When producing footage with conventional SDR, the camera exposure is adjusted based on unified video level, and the white signal is adjusted to 100% of video level. However, no such regulations have been established for producing content in HDR. With no operating experience to rely on and no recommended shooting conditions, the issue becomes identifying the standard and levels to use. Graphics that include textual information are very important when producing content. As mentioned previously, it will be possible to set a certain level with white at 100% of video levels as the standard. However, no such regulation exists for HDR. For example, if white is set to 100% of video level for HDR, as it is with SDR, and there is a scene where superimposed text is multiplied, then the superimposed text will be extremely bright in comparison to the overall footage. Production guidelines related to these issues have been formulated internationally. In order to contribute to develop them, we correct parameters in HDR production. NHK has run HDR production trial for a variety of programs and has accumulated significant data gathering experience during production. This table presents some of production data, base level, high level, and so on. Next, I'll show you some examples of technique in use. Here is an example from an international soccer tournament held from June to July, which was produced in 8K HDR. Rather than being broadcast live, two preliminary league match and one final match were recorded with 3 cameras. The footage was edited after returning to Japan. The brightness of glass on the field was set to 50% as a base level. The audience stairs were 85% as a peak level, and players' faces were 75%. Subtitles were generated by combining output from provide HD system and a HD subtitle generator. The output was up-converted to 8K and superimposed using a switcher. The overall footage balance was adjusted so that the white of the subtitles would be about 80%. Baseball is one of most popular sports in Japan. High school tournament matches were produced as 8K HDR programs and broadcast live. An 8K obi-ban was used, while 6 cameras were placed around the field. Footage was captured within a high dynamic range under natural lighting. An attempt was made to produce footage that truly took advantage of HDR benefits, in which lighting conditions continually changed, such as scene of players with audience seating, or landscape shots of the field together with the sky. Accordingly, the wide color gamut was able to reproduce colors of uniforms and audience as real scenes in order to reproduce an atmosphere of a traditional stadium. We set the level of the clay field to 30% HLG as base. The blue sky was 85% as the peak level, and the grass on the field was 55 at the midway level. The subtitle level was 85%. Sumo wrestling is a Japanese traditional sport. HDR programs were produced for SHV broadcasting during a professional small wrestling tournament, which was broadcast live. An 8K obi-ban was used, while 6 cameras, 3 8K cameras, and 3 4K cameras with up conversion were placed around the dohyo stage. The percentage of the data was converted to HLG. The ring made of straw was set to 60% as base level. The small wrestler's shoulder was 75 as peak level, and small wrestler's face was 55% as midway level. The subtitle level were 75%. Finally, as a general trend, these production tended to involve sports played outdoors, where the overall background level for graphics during fine weather is high. As a result, we were cases where the color would look closer to gray if superimposed text with a high level. Around 80 to 85% was not matchable, even though one would think that doing so would multiply the white color. Conclusions. We developed signal converter for simultaneous HDR-SDR production. They support the conversion of color gamut, gamma, and HDR and SDR resolution at the same time. We are still in the early days following HDR standardization, and equipment and display required to produce programs continue to evolve. We will continue to study HDR production methods and develop and establish equipment capable of producing high-grade footage more efficiently. Thank you so much for taking the time to attend this presentation today.
Thank you. Well done. Good. So, come on, guys. Any questions? Right. So, short. I need to manage that a little bit because of time. The row is closing now. So we have those 4 questions and short questions.
Craig Todd Dolby, if you bring SDR content into an HDR production by upconverting, and then you take that HDR production back to SDR by downconverting, what is the relationship between the original SDR image and the final SDR image. It's a round trip conversion up and down. Does it come out the same, or is it
SDR,
altered?
Yeah.
Up converted, down converted
Yeah.
to SDR.
Yeah.
How do the two SDRs look like?
How do?
Quality-wise, what is the comparison of SDR
Yeah.
up converted, down converted to SDR?
Yeah. How?
Quality, is the quality good or bad?
Sorry, sorry, I couldn't catch that. Please speak more slowly.
Okay, so I have HDR production.
Yeah.
Some of the source may be SDR, legacy. So you upconvert to HDR to
Yeah.
include. Now my HDR production is finished, but I have to distribute over some SDR. So I downconvert HDR
Yeah.
to SDR.
Yeah.
So my original SDR content
Yeah.
went up and down.
はい。
How does the output compare to the input?
Okay, I understand. It's maybe it's equal up converter and down convert footage is almost equal.
Almost
Almost.
equal.
But sorry, I don't speak English well. Sorry, but it's difference in conversion. Sorry, I speak. Sorry.
Maybe you catch up afterwards.
Hello. So my question is, in what you've presented is very hardware-based. It's physical converters with SDI cables. And there was one example on slide 20 where you're talking about doing a conversion and then having editorial for 20%. Do you have any thoughts on moving beyond hardware and going towards software-based approach? So instead of doing a destructive Rec 709, you could actually generate metadata from your source so that we could do everything editorially with metadata instead of a hardware-based approach, as we've seen.
What do you think?
Instead of hardware, more software-oriented
Yeah.
productions.
Yeah.
Do you plan to do that?
Sorry, I don't speak English well. Sorry.
Understood.
Let me check and get back to you, okay?
Sure.
Sorry.
Excellent.
Yeah.
Thank you.
One last quick one.
Sorry.
I'll make it quick. It's again on slide 20. If you want to switch that as a reference, that might help us talk about it.
Okay.
When you talk about adjusting the levels, what is it that you describe? Is it like a black level shift, a white level shift, a tone shift? Back one more. So right there on the editor section, what kind of levels, what are you describing? What information is being adjusted there? Can you be more specific?
Level?
The level adjustment.
Yeah. It's about to compare to SDR and HDR. It's about 10 to 12 decibel HDR to SDR gain.
Okay.
Yeah.
Thank you.
Thank you. I think you will be around to catch up a
Yeah,
little bit with the
sorry.
colleagues.
Sorry.
But thank you for your presentation. Thanks for taking the efforts.